everybody, and welcome back to the Zeiss Innovation Rocks. My name is Pietro, I'm your host, and this is rock number 6. Yesterday, we started our autumn edition with rock number 5, where we talked about our innovations within Zeiss optical series. I hope you did enjoy both the show and the webinars. Today, we stay in the world of Zeiss optics. We stay in the sub-microscopical world of Zeiss optics, to be more precise, with the new guest and, of course, interesting demos with our demonstration master, Jay. The title and the topic of this rock is Rethink, Reimagining, Reinventing Optical Inspection and Technical Cleanliness. And as my knowledge of this topic is admittingly quite limited, I'm happy to have a guest. He is the head of Industrial Microscopy Solutions at Zeiss. Welcome, Robert Zarnetta. Hello, Robert.
Thanks, Pedro, for having me.
Thanks for being with us. Well, Robert, in our intro video, we caught a glimpse of the history of microscopy in Jena, Germany, called Zeiss, actually stands for the history of microscopy. But today, we are certainly not here to talk about the past. We want to talk about the present and even more about the future of industrial microscopy. Robert.
Yes, and since 170 years, where we started back building the first microscope, we had built quite a huge portfolio for our customers in the microscopy world based on best optics and best mechanics. And so we're able today to serve all major applications for our industrial customers with our microscopy solutions.
Okay, what kind of applications are we talking about in more detail?
The most important application is failure analysis. People really have to understand why things break, and this is where microscopy can help. We will talk today more about optical inspection and documentation and technical cleanliness, which really looks at particle contamination of parts. But we should not forget roughness and topography, so perfect surface finishes, and the metallography application, really understanding the core of the material itself.
So quite a lot of solutions. So now is your chance to pitch for your employer. What makes Zeiss's solutions so unique?
I think what makes Zeiss unique is the breadth of the portfolio. So we cover everything from light to confocal to electron microscopy, and we combine this with the most powerful Zen Core software suite to enable our customers basically to do the imaging they want, the data analysis, and connectivity of all those equipment throughout their factory or even globally.
Well, that sounds already like a broad, very broad field of application, but today we are about to experience not one, but two innovations, aren't we?
Yes, we will show a true innovation for technical cleanliness and a revolution for optical inspection and documentation.
A revolution for optical inspection. So now let's start with this revolution and let's have a look together. The Zeiss Visioner 1 is that revolution. Looks good, but what makes it so revolutionary, so special?
We solve one fundamental problem of microscopy that all our customers face. And this is, if the things get very, very small, you really have to crank up the magnification, but this comes at a cost. And this is a limited depth of focus. And this is just the law of optics. And we can't break it, even as Zeiss, but we can bend it. And this is what we introduce here with the Visioner 1. It's all-in-focus imaging in real time.
All-in-focus imaging every time, in real time, and for the first time in the history of microscopy, right?
That's true.
Sounds too good to be true, but how is this focus achieved?
We use quite an innovation in the MEMS technology. It's called a micro mirror array lens system. So this is a MEMS device that can produce incredibly fast focus variations, and it's made of little mirrors that we can individually tune to resemble different optics. And by this, we can switch them so fast that we go to a complete volume, focusing at every point and create real-time, all-in-focus imaging.
Okay, well, I'm quite practically thinking guy, so what does this practically mean for your customers?
Bending the physics and the optics means 100 times more depth of field for our customers instantly, and up to 69 millimeters of all-in-focus imaging.
Okay, and you said those micro mirrors adapt a couple of times per second. How fast do they adapt?
They are very, very small, and so we can switch them up to 20 kilohertz. So incredibly fast, and you won't see a difference. It's real time for the human eye.
20,000 times per second. Well, then I'd say we can't wait any longer. We want to see the Visioner One in action. So Jay, if you're there and if you're ready, show us how the Visioner One works.
Thank you all very much for joining us, and I'm here with Paul, who's going to show us the Visioner One. But before we start, Paul, can you tell us about yourself?
Yeah, my name's Paul. I'm the Solutions Manager for Visioner One within the Industrial Microscopy Group.
Awesome, awesome. Paul, well, thank you for joining us. We appreciate you coming in.
You're welcome.
Robert said that this was super easy to use, so how do we start?
Yeah, absolutely. So let's take a look at a sample under the traditional inspection system.
Okay.
Should have moved that.
Yep. All right, so I got, I'm not very good at a STEMI, but I am able to, this is a really, has a shallow depth of field, so I can get the top tack sharp, but I can't get it through the sample.
Yeah, I mean, this is a typical challenge that customers face when they're looking at samples under a traditional system.
Yeah, I can imagine.
So let's move the sample over to the Visioner One and then let's see what you see.
Oh, I'm going to do it.
Absolutely, yeah.
Oh, man, all right. Are you even going to touch these machines? It's just all me?
It's all you.
All right. Whoa. That was fast.
Yeah.
That's it? Just
Yeah.
crazy.
Absolutely. So what you're seeing now is real-time extended depth of field imaging.
This is real time.
This is real time.
I can move this.
Absolutely.
I'm going to move it.
Yep, move it around.
All right, here we go. Wow, look at that. That is crazy. That's focusing. How does it do this?
So basically we're incorporating MALS technology into the system, and that is what is delivering the real-time extended depth of field image that we're seeing right now.
Oh wow, that's crazy. How would someone learn more about this?
Okay, so if you want to learn a little bit more about this, or a lot more about this even, then join our webinar. So the webinar will run through the technology in a little bit more detail, the applications that it's really, really useful for, as well as how we can do documentation, measurement, and also some 3D imaging.
Yeah, I'll tell you what, I am an optical guy. This is something I've totally never seen before, so I will definitely be at that webinar. And y'all, it was that easy. This is the shortest demo we've done so far. So with that, I'll kick it back to the studio.
Well, it was short, but it was good. Thanks a lot, Jay and Paul. What can I say? The images delivered by the Visioner One, they look so perfect, they almost seem, unreal or computer generated. Well, but now, Robert, let's talk about the other element to consider, which is the technical cleanliness.
Yes, so we have just seen the inspection, which is an important step to say everything is okay with the part, but there can still be contamination on those parts, which can be very critical if you start assembling components, like in an engine or in a battery stack, or in medical devices that finally end up in your body. You really want to avoid particle contamination. And this is where technical cleanliness comes into the game, and we are showing quite a tremendous improvement in the productivity of our customers really doing this technical cleanliness analysis that they have to do by standards, by really improving their productivity, introducing a new camera technology that makes things much faster.
Make things much faster. Or I read there, make the right decisions faster, which means time saving. So how much time can be saved? Can you give us some figures?
By introducing this new technology in the camera, today customers have to do 2 scans to differentiate between metallic and non-metallic particles, and we simply reduce this to 1 scan, saving half of the time. In the complete workflow, this gives them 30% more productivity.
30% is quite a lot. Well, I think now it's time to see this new innovative device for technical cleanliness analysis. Not in action, but what it looks like. Well, this looks fantastic and the video is quite self-explanatory, but as before, we want to see it in action. What you say, should we hand over to Jay?
Yeah, let's give it to Jay.
Okay, well, Jay, the stage is again yours.
Thanks very much, y'all. Appreciate it. I'm here with Werner, the product manager for technical cleanliness. Werner, I have a very, very big admission to make. I don't know what technical cleanliness is.
It's everywhere. Contamination is everywhere, and our job is to find out where the contamination is. And we have got a new product where we are well able to find out where the contamination is.
What type of samples are they?
Of course, we have got different samples. We have big samples, like the housing of a breaking. We have small samples, smaller samples. That's, for example, for medical.
Sure. We need that
Yes.
clean.
And we have got very small components. That's, for example, a dental implant.
Wow.
So you can imagine that all these different kind of components must be very, very clean.
Sure, sure. So I think I understand what it's for. Can you give us an example? Let's dive a little deeper. How do we implement technical cleanliness?
I will show you. I'll give you just one more explanation to that. Technical cleanliness is an indirect inspection of particles. So we take the components and we make them clean with a lot of specified professional cleaning equipment under high pressure with water, with air, in order to get the particle extracted and to get them filtrated. And as you see nothing.
Yeah.
It's
Filter.
just too small.
Yeah.
So, and that's where, of course, our workflow starts with our new software. We try to get all information which are on this filter into our software. We do the analysis of the filter in order to be clear about our contamination levels.
Sure, sure. How do we do that?
That's one of our major instruments. It's the Access Zoom V16. And the new technology we are able to offer is a new camera. So usually you need to do the scans, you need to do 2 scans. We are able to run it with 1 scan. And you can see the filter is packed. It's packed with particles.
Packed with particles. It is not clean the way
No,
my
it's-
eyes saw it.
It's not clean, and you
Yeah.
see a lot of different particles. You see big ones, you see long, you see white ones, you see fibers, you see a lot of things. And of course, our job is to find out what's it all about. And we have got great software to show all the results on one single page. Here we are.
Wow.
We have got all the particles which are on the filter on one single page. And in comparison to the whole market, the combination of acceptance criteria, immediate approvals, and all this different filtering, it's unique in the market. Nobody else has it.
No one's seen this before.
No.
Wow, that's crazy.
That's really great and very powerful.
Okay, I have a question. Now we understand that there is a particle, right? And it's per the specification. If you're working with medical, then it's per the medical specification. But we have a particle. What do we do from there? We've determined there's one. Is there something, is that actionable now?
Yeah, well, it's the most important question is, of course, for industrial production, how to avoid a particle.
Sure.
So, because particles are everywhere. So, the trick is to take that correlative particle holder and approach it to our scanning electron microscopes.
Our scanning electron
Yeah.
microscope. Okay.
Okay,
Cool.
so we have the same particle holder. We give it to our electron microscopes. The particles of interest, which we marked before in the light microscopes,
Got it.
will be found automatically in the electron microscopes.
Don't have to refine it.
You don't have to refine it, and with our ADX system, you immediately create the chemical footprint of the particle, and you know where it is.
People will have questions. Where can we go to learn more about technical cleanliness?
Yeah, if you want to stay tuned, visit our webinars. We have plenty of things prepared for the webinars, so just join.
Will do, will do. So that was technical cleanliness. Thank you for taking it.
In a nutshell. In a nutshell,
right? Thanks for taking the time to show it to us. And I'll see you at the webinar, and I will take it back to the studio.
Thank you very much, Jay and Werner. Well, what can I say with the two devices that we have seen today? We're looking at two huge and highly beneficial innovations in the whole sector of industrial microscopy, don't we?
Yes, and it's all built on our Zen Core software suite. So really enabling our customers to use the different technologies from light to electron to confocal microscopy in a seamlessly connected way. This is where the benefit comes, and not only for those single applications, but also in highly regulated industries. What makes us unique is providing what we have seen today, inspection, technical cleanliness, also for FDA-regulated medical customers. And this makes our solutions at ZEISS with this complete portfolio and software quite unique. And I hope our customers will like it.
Perfect. Well, thank you very much, Robert Zanetta. He is the head of industrial microscopy solutions at ZEISS. And thank you, dear ladies and gentlemen, for watching Innovation Rock number 6. Right after this show, our webinars will start, where we will address today's topics in a lot more detail. Don't forget to click the link below to register for free. My name is Pietro. I hope that you enjoyed this show as much as we did, and I'm looking forward to seeing you tomorrow for the next one. Bye-bye and take care.